Hey there, welcome to the 2025 On-Farm Network research results. I'm Chris, On-Farm Network agronomist with the Manitoba Pulse and Soybean Growers. On-Farm Network is very much a team. We have 5 of us in the field taking data, collecting data all season long. It's a team effort, and I want to acknowledge Ian, Ashlyn, Grace, Bryce, and myself from the 2025 team. Our old On Farm Network logo is on the left, and our new logo is on the right. I'd like to know what you think of it. Is it an improvement? I'd like to make a plug for our 2026 season trial options. We have a list, but it's not necessarily the only options. If you have a good idea, please get in touch with me. My information is on the screen. All of our on-farm network single site reports are found on our database at manitobapulse.ca, where you can filter by crop, year, trial type, region, and even if the results were significant or not. All participants will receive a single site report after harvest. This is usually coming around beginning to middle of December, and it contains a summary paragraph, trial information, any data that was collected on the trial, yield results, and NDVI image, and it even includes a economic summary. Just a quick word on statistics in our results, and we use a 95% confidence level when analyzing our results. And we use a replicated strip trial and a statistical method called an analysis of variance to get a p-value. And if the p-value is equal to or below 0.05, then we say we are 95% confident and the results are statistically significant. And this basically means that we can say about 95% of the time the yield difference was caused by the treatment and not something else like pure chance or field variability. A lower result than 95% just means that we are less confident of the result, and therefore we say that it was not significantly different. And then just with the graphs, here's an example of 3 bars. We have the A, which means that it was significantly different from the B, and the A and the B is the same as the A and the B. So the A was significantly higher than the B, and the AB was the same as the other two. So in 2025, we established 63 trials, and then 58 of those were taken to harvest. 37 soybean, 9 pea, 10 dry bean, and 2 fava bean trials were completed. I'm not going to have enough time to go over all of those here today, but we can look at soybean seeding speed, seeding equipment, dry bean inoculation, dry bean fungicide, pea fungicide, and fava bean insecticides. Since 2012, we've had 34 trials involving 4 different crops and 210 different farmer participants. We do operate all across Agro Manitoba, but our trials are often concentrated to where the crops are most often grown. So that means more concentration of soybeans in the south central region. Dry beans are, east, central east. Dry beans are often concentrated to the south central, and peas are concentrated more towards the north and the west. We have quite a large number of trials completed over the years, And while in the past we were focused on getting as many trials completed as possible, now we're more focused on the quality of those trials and trying to collect more and more data on each one in order to be able to say why a result happened rather than just what happened. And this provides an additional service to our farmer members. So I'll start off with the on-farm network trial summaries from 2025 in soybean. We did have a new trial called soybean seeding speed, and we wanted to know if seed placement, depth, plant spacing, and ultimately yield are sacrificed when seeding at faster speeds. And we all want to know what happens when we go faster, right? Will the yield totally fall off a cliff or will everything be okay? So we had 8 soybean seeding speed trials located by the green dots. And 3 trials compared 5 to 7 miles per hour, and 5 trials compared 5 to 7 and 9 miles per hour. And that 7 miles per hour is, for the purposes of this trial, deemed the farm's normal speed. With that, then we had the lower, slower, and faster speeds as comparison. The equipment used was a planter at 6 of these trials and an air drill at 2 trials. And the data collected was plant to plant spacing or plant spacing uniformity, seed depth, plant emergence, and late season plant survivability, yield, and we even looked at the fuel consumption from the tractor. So getting into the results, seed depth for each speed, and we found no significant seed depth differences at any of those trials, comparing the 5 and the 7 miles per hour, or any trials comparing the 5 to 7 to 9 miles per hour. And we did use a post-emergence seed depth assessment where we're digging up this young seedlings and looking or measuring from the root hairs up to where the color changes, because that is the uh, point where the soil surface is. And we did look at plant-to-plant spacing or plant uniformity. Some might call it singulation at the 3 different seeding speeds. And this is definitely not as critical to have singulation with a soybean as it is for, say, corn. And this is the reason why it is certainly acceptable to seed soybeans with a seeder or a planter. And we wanted to see what would happen if, when you go faster, is the plant to plant spacing reduced? So that is those sort of uniform gaps between plants. And the way we measured it was we took a seeded row of plants and laid a 10-foot tape measure beside it. Then we recorded where each plant was on the tape measure, and then we calculated a standard deviation from those measurements. And for the plant to plant spacing results, 2 trials showed slightly less uniformly spaced plants at the fast or 9 mile per hour speed when compared to the 7 mile per hour speed. And both of those were surprisingly both established with planters and not air seeders. And there were no plant uniformity differences at the other 6 sites. Now for the plant stand and yield results. First, look at the graph on the left side. And on the y-axis, we have plant stand counts as a percentage of seeding rate. And along the bottom, we have the average early season establishment and average late season survivability for each seeding speed. And across all sites and equipment types, the average plant stands at establishment and late season survivability were not affected by seeding speed. So there was no plant stand penalty by seeding faster. And then if we look at the yield graph on the other side of this slide, We found that there were no significant yield difference between the different seeding speeds at any sites. Note that there's no letters above any of the bars. Essentially, it means changing the soybean seeding speed did not lower the yield at 8 out of 8 trials. Of course, there are advantages to seeding faster. And when you want to seed as many fast acres as possible in a time span to hit an optimal seeding window, and knowing that yield is not potentially not sacrificed, that is quite huge. But this is a preliminary finding only, and we really do need more data points before we can make a solid recommendation about seeding speed. And then moving on to another new trial that we had in 2025, where we compared head-to-head soybean air seeder compared to a planter. And who would like to know the winner of that? So we compared an air seeder with a 10-inch row spacing or solid seeded to a planter on wide rows, 30-inch rows at 2 sites. The air drill was a Bourgault, and the planter and the air drill had disc openers, while the planter was a John Deere. And at one site, we had a mid-season maturity variety and a long season maturity variety at the other site. We looked at emergence, plant survivability, disease, and yield. And both of these sites were located in the RM of St. Clements. So in the top photo here, at one of those sites, the planter rows on 30-inch spacing actually did a lot better with emergence than the 10-inch spacing. And this shows the plants on June 10th at V1 stage. And the whole trial was seeded on May 5th, and it struggled getting out of the ground due to soil crusting. And so what happened was the seedlings in the wide rows were better able to push up through the crust with many seedlings working together, and it had better emergence where the 10-inch spacing had patchy emergence that was done with the air drill. And then on the bottom photo, this is how the crop looked on June 26th of V3, and it was starting to even out a bit. At this trial, we measured the percent canopy closure at 3 different crop stages. And this photo is taken, and the Canopio app then calculates the percent crop cover or percent with leaves or plants compared to the bare soil. And at that one site, this is how the 2 different row spacings and equipment treatments looked on August 9th, or August 19th rather, at R5. On the right, the canopy in the 10-inch spacing was completely closed. And on the wide rows, there on the left, there was only about 85% canopy. And this was significantly different. We also counted weeds in each treatment, and there were significantly more weeds in the wide rows. On average, there were 22 weeds per half a meter squared in the wide rows, and only 5 weeds per half a meter squared in the narrow rows. And this indicates superior weed competition with the narrow rows. Diseases were also rated at these trials twice, 2 weeks apart at the R stages, and there were no significant disease differences between row spacings. We looked at the following diseases on the screen, but there was relatively low participation in the growing season at these sites, resulting in low disease pressure. Here the table shows us that the big difference in establishment at the O2 trial due to the soil crusting, circled here, where the narrow rows had far fewer plants emerge compared to the wide. And more importantly, we saw no difference in yield between the wide rows with a planter and the solid seeded with the air drill. In the end, at that site, the lower plant stand did not negatively affect yield as the crop was compensating nicely. And these are, of course, preliminary results with only 1 year's data. And so we won't make any recommendations at this time of planters versus air seeders. So now we'll move on to trial summaries in dry bean, starting with dry bean inoculant trials held in 2025. And dry beans are relatively poor nitrogen fixers compared to soybeans. And as such, they are typically fertilized with nitrogen-like non-legume crops. But the goal here is to find commercially available inoculant products that can effectively colonate the root zone with rhizobia and then potentially improve dry bean nitrogen fixation and reduce our reliance on nitrogen fertilizer. There is ongoing research into finding better inoculant products in dry bean here in Manitoba with Kristen McMillan at the University of Winnipeg, or University of Manitoba rather, and Dr. Ivan Aresnik. Just a side note, but an important one, is that Manitoba pulse and soybean growers guidelines are targeting 70 pounds nitrogen as a combination of soil residual nitrogen and nitrogen fertilizer target for an average crop of approximately 1,800 pounds per acre. So that's nitrogen coming from any source. So we tested no inoculant with inoculant, but an important part of nitrogen fixation is how much nitrogen there is in the soil already. And generally, nitrogen above 35 to 65 pounds per acre, nodulation and effective nitrogen fixation is inhibited. So we must take this into account when we analyze the results. At 3 of these trials, we aim to test the farm's normal practice of dry bean production with additional nitrogen and no inoculant compared to no nitrogen but with inoculant. So at dry bean inoculant 01, we had a spring soil test of 55 pounds per acre, and we looked at no inoculant but with the 65 pounds per acre N compared to a product called Legume Fix. At O2, we had a spring soil test of 89 pounds per acre nitrogen, and the farmer compared no inoculant to Legume Fix, but they broadcasted 75 or 70 pounds per acre nitrogen across the whole trial area. At O3, there was a lower spring soil test with 16 pounds per acre nitrogen, and we had the 3 treatments of no inoculant, no nitrogen, and we call that the control, compared to a product called Boss Pete. And the last treatment was no inoculant, but with a blend containing 35 pounds per acre nitrogen. Lastly, at O4, we didn't get a soil test, but we estimate it to be about 30 pounds per acre nitrogen, comparing no inoculant with 60 N compared to Legume Fix. And I'll point out that all of these inoculant products are peat-based and were applied directly to the seed. This is how O4 looked at V8 stage on July 17th near Boissevain. And on the left side of the photo, we saw the plants that had additional 60 pounds per acre nitrogen and no inoculant were definitely greener at this stage than plants on the right side of the photo with no nitrogen fertilizer with inoculant. The color of the plants did even out between treatments around flowering, however, and plant greenness doesn't always correlate into yield, especially with an N-fixing legume. And the less green plants yielded the same as the more green plants in the end. When we counted the number of nodules for each treatment, we found significant nodule number differences between the treatments at each and every site. But there certainly wasn't a clear pattern, even whatsoever. So on the one hand, at trials 01 and 04 with the arrows, the inoculated strips had significantly more nodules than the no inoculant strips. And great, that's to be expected, that there would be perhaps more nodules on plants with inoculant compared to plants without. But the opposite occurred at the other two trials. At O2, the no inoculant strips had significantly more nodules than the inoculated strips, so that's the exact opposite. And at O3, the with nitrogen no inoculated strips had significantly more nodules than the inoculated strips and had the same number of nodules as the untreated control. Only speculating here, but the reason for this could have been that the native soil rhizobia were outcompeting the introduced from the inoculant rhizobia in the soil at these sites. And at 04, we did do a in-season plant tissue for nitrogen test, and we found no differences between treatments and total nitrogen in the plants. And the soil test in the fall also showed no differences between treatments with nitrogen. But the only significant yield difference occurred at 03, where the no inoculant with nitrogen outperformed better than the other two treatments, and yield and profit was increased as a result. So that is simply nitrogen fertilizer outperforming the inoculant, which didn't perform. So in summary, at the one site, 03, the site had low soil test nitrogen of about 16 pounds per acre. So it would not be unexpected that the beans responded positively to the nitrogen fertilizer blend. And clearly the Boss Peat inoculant tested did not provide a yield response. At 01 and 04, inoculation performed the same as nitrogen fertilizer, which has some potential cost savings if the reason for maintaining yield was in fact due to the inoculation. And this brings me to the last point. Without a controlled treatment of no nitrogen and no inoculation, we simply can't know for sure if the inoculation is performing well. We do know that beans respond to nitrogen fertilizer, but we have also seen that adding little or no nitrogen can also provide a good yield. But without that control, we can't say for sure that the inoculation provided the plants with the nitrogen from biological N-fixation enough to provide the yield bump, or if the yield came from other sources. So more testing with more control strips in the trials will be needed, and we hope to keep testing this in 2026. So long-term dry bean inoculant results, we've had 9 trials all time with a single inoculant compared to no inoculant. And we only had one significant and economic response, and that was due to the added nitrogen fertilizer from that trial I just mentioned, held in 2025, and it's circled here with the triangle. So as for long-term dry bean inoculant results, it's hard to tease out potential return on investment of inoculant versus nitrogen fertilizer at this point. And more testing is definitely required once more products become available. Inoculants run from about $3.50 to $9 per acre, and we've tested a number of different products. So I'll move on to dry bean fungicide trials held in 2025. What are the effects of a single foliar fungicide application on white mold, yield, and did it provide a return on investment? We had two trials both located in the RM of Rhineland. And at dry bean fungicide 01, we had 3 treatments untreated compared to fungicide Proline Gold. And the third treatment was Proline Gold tank mixed with a biofungicide called Serenade Opti. At 05, we had just untreated versus Proline Gold fungicide single application. All of these were single application compared to none. And the data we collected at these sites was plant stand, disease ratings, and yield. All of these applications took place at R2 at the early pin pod stage. At 05, we had severe white mold infestation, and it did look quite bad in some patches in the field. And at 01, we did have quite a lot of rain in July, especially with 160% of normal rainfall in July. And at 05, we had over average rainfall as well in July with 119% of normal rainfall as well. So that would explain why there was a high white mold infestation at least one of these sites, but we didn't see any white mold severity differences between treatments at either site. We have white mold severity on the y-axis on the left of, we rate the plants 0 to 5. And on the bottom, we have the trials with the untreated and single application values. So at 01, we saw no increased yield with the fungicide or the fungicide with the biofungicide. And this did result in a loss in profit of about $25 per acre for the Proline and a total of $38 per acre when you add up the Proline and the Serenade Opti together. So no difference in yield between the 3 treatments. The farmer was better off not treating. And then going into dry bean fungicide 05, where we did see the higher pressure yield, white mold pressure, and we did see a significantly increased yield with the fungicide application, and the farmer profited an extra $155 per acre. And this is based on a 32-cent per pound black bean price and $25 per acre for the Proline Gold. So on-farm network trial summaries of dry bean single application versus untreated fungicide from 2016 to 2025. We have completed 22 trials shown here on the map, and there have been 3 trials with significantly different results between the treatments. So on the y-axis on the graph, we have the percentage of plants with white mold or incidence and the individual trials along the bottom. The graph bar pairs show the white mold incidence for both the single fungicide and the untreated. And at 2 of the 3 sites where there was a yield increase with a single fungicide, and this is shown by the 3 circles along the bottom, we found no white mold in our ratings at 2 of those. So this is an example of how in low risk years with low disease incidence, we can still see a yield difference with the fungicide. But I will say it is possible that the white mold showed up after we went for our ratings and we didn't catch it. So, except for 2025, there was lots of white mold, but no difference in ratings between treated and untreated. So, we did see a single fungicide application improve yield at 3 of the 22 trials all time, and that works out to be about 14% of the time. And on average, improving yields by 364 pounds per acre. And this did provide a return on investment for the single fungicide application. As always, you want to manage your white mold risk, and we do have a nice worksheet that you can use available on our website to help decide on if and when to make fungicide application in dry bean. So moving on to field pea fungicide trials. We did have 4 trials where we compared a single application or a single fungicide application to untreated. And we wanted to know what was the effect on disease pressure and yield and the return on investment. And then we did have one trial where we looked at a single versus a double fungicide application. And we wanted to rate the same things, disease pressure and yield and return on investment. So these are where the pea fungicide trials were located, with the double versus single up in this north in the Swan River area, which is circled. With the single versus untreated trials, we had untreated versus a single application. And then at 3 of those trials, we did have a single fungicide tank mix with a wave biological product, which is meant to help the plants cope with abiotic stress. We looked at ReviPro, Xelera, Delero, and Zetigo PRM, and we collected plant stand disease ratings and yield data. And the 3 trials were located in Dauphin RM and Woodlands. All of the single applications happened at the R2 stage, or early flowering. And then moving on to the double versus single trial, we had a single application of Delero compared to 2 Delero applications. The first application made a R2, and then about 7 to 10 days later, the second application of Delero was applied at R3. And we looked at plant stand, disease ratings, and yield. And that trial was in the Swan River. And on-site weather stations were happening at all 3 of those trials, with real-time monitoring of Ascochyta and Microspirella blight. And these weather stations did have disease modeling activated, and this was a test first year for us to look at that data, and it will help us decide if and when to apply fungicide. And this is just an example of, I won't get in too much into the details, but it's in the circle here, it basically means when there is a high risk of disease, the model will tell us when there's a sporulation, and then that translates to an infection that will potentially show up in the near future, meaning that at that time, when there is a high infection, control measures should be taken. And this is an example of one of those sites at PFO1 in Dauphin. The fungicide application was made on June 24th, and this is circled in the orange circle there. But the infection was 0% at that time, indicating a low risk of infection. The model did show there was an infection later on at around July 14th, with the red triangle and the orange arrow, but the optimal application timing window had already passed, meaning that it was largely ineffective with the fungicide application at the time that it did occur. And then we looking at the fungicide disease rating results. We have the Ascochytus severity scale of 1 to 7 on the left, in the left graph here on the y-axis, and then the different trials with the treatments along the bottom. And then we didn't find any differences in Ascochyta disease ratings at any site in 2025. And then on the right, we have the yield in bushels per acre, or on the right graph rather, with the different treatments and trials along the bottom. And we didn't see any significant differences in yield between treatments either in 2025. So the long-term results for single versus no fungicide application trials in peas from 2017 to 2025 are 42 trials, or we have completed 42 trials. And 24% of the time, a single foliar fungicide application has been significant and economical. And at these sites, when significant, yield was increased by an average of 5.8 bushels per acre, and profit was improved by $18 per acre. And this is based on current pea prices and about $20 per acre fungicide cost. And then for the double versus single fungicide application trials long-term results, we've looked at 24 trials from 2017 to 2025, and 29% of the time a double foliar fungicide application has been significant and economical, and where significant increased yield by an average of 5.1 bushels per acre, increasing profit by about $13.50 per acre. And that's also based on current pea bushel price of $6.50 per bushel and $20 per acre fungicide. So the last trial I'll go over now is the fava bean insecticide trial that we had in 2025. This was also a new trial for us. And we looked at controlling lygus bugs. And the background here is that lygus bugs generally don't limit fava bean yield, but lygus bugs do pierce pods, and that's shown in the picture on the left here, which downgrades the seed, and the grain will be less valuable. But economic thresholds are not well established for fava beans, but some agronomists suggest a low threshold, as few as 5 lygus bugs per 10 sweeps during the early pod stages. And I'll note that lygus bugs perforations below 1% do downgrade the seed from a number 1. This is an adult lygus bug shown in the right side of the picture here, and it has a characteristic triangle on its backside. We did test no untreated or not treated with insecticide versus single application of carbine from FMC, and it was applied foliarly at R4 at a rate of 81 grams per acre. And then we looked at the main gauge here to test the performance of the insecticide was the seed perforations. This trial was located in the RM of Argyle. And the application was made at R4 or flat pod stage. And in the pre-application sweeps, I was finding about 3 to 4 lygus bugs per 10 sweeps. So that wasn't quite at the threshold, but they were definitely still present. This is how the trial was laid out. It is not a the good seed or grade number one here in the bottom, the large fraction with the arrow, we had cracked seed. There was a significant number of discolored seeds on the top. And then we have our perforated seeds with the third arrow here on the right side of the pan that were perforated by a lygus bug. So anything but the main group here, the in the circle, will cause downgrade. So getting lastly, I do want to make a plug for like one trial we had this year. It was an on-farm precision experiment where we were having a new trial layout of not strip trials, but rather it's a precision agriculture experiment with variable seeding rate. And this does occur in a random pattern all across a quarter section. This gives us more replications and more statistical power than a regular strip trial to be able to use the data to make more informed decisions. The trial was actually established in 2025 and it was located near Selkirk. And we wanted to see what is the most profitable